Hello, so this is the second kind of lesson on the simplex algorithm. So this time we're going to use one with more than two variables. So we're going to use three variables. So it wants us to maximize this subject to these three constraints here. And then, so the first thing we need to do is to make it into a simplex problem. So we've got less than or equal to, so we know we can use the simplex algorithm. The first thing is to add in the slack variables and make them equalities rather than inequalities. So it would be to maximize. We want to take all of this over to the left-hand side. And have it equal to 0. And it will be subject to 3x plus 4y plus 5z plus s1. Again, you can use r, s and t if you want. Equals 10, x plus 3y plus 10z plus s2 equals 5, and x minus 2y plus s3 equals 1. And then our non-negativity ones, x, y, z, s1, s2 and s3 are all greater than or equal to 0. So now we've got it like that, we're ready to put it into a table. So I'll just quickly draw the table with the video paused and then come back to you. Okay, so I've got my table drawn. The left-hand side is the basic variable. I've got x, y, and z because they're the variables in my problem. Then I've got my three slack variables, so s1, s2, and s3 in my case. The value, which is the right-hand side, could have written that. And then this is the ratio. I've used theta for that. And then my row operations, which are a bit squashed on the right-hand side, but I can get them in there. So to put the initial problem in the table, remember that the objective function goes at the bottom. So we need to do the constraints first. So here the basic variable is s1. I've got 3x, 4y, 5z, 1s1, 0, s2 and s3, and the right hand side is 10. The next constraint, the basic variable is s2. I've got 1x, 3, oh, that should have been a y there, 3y, 10z, no s1s, 1s2, no s3s, and the right hand side is 5. And then the third constraint, s3 is the basic variable. So these are the ones that are non-zero at the start. Because we're starting at the origin, x, y, and z are all 0, but our slack variables are the ones that are non-basic. So I've got 1x minus 2y, no z's, 0, 0, 1 s3, and the right-hand side is 1. And then just to put my objective function in, p minus 3 minus 5 minus 2, 0, 0, 0, 0. Okay, so that's my initial tableau set up. So if you're asked to do, sometimes that's all the question will ask you to do. So the next thing we need to do is to decide which is the pivot row and which is the pivot element. Sorry, pivot column and pivot element. So in order to do that, to identify which column it is, I look for the most negative value in the objective function row, in the objective row. So it's that minus 5 there. And so I know it's going to be in this column here. And then, so that's my pivot column. And then I need to work out theta, the ratios, to work out which of these elements it is. So we do the right-hand side divided by the corresponding number in the pivot column. So 10 divided by 4 is 2.5. 5 divided by 3 is 1 and 2/3. This one is negative, so we don't need to worry about that because we always want the smallest positive one. So actually we don't even need to bother working that one out. If you do, though, it doesn't lose you any marks. And we're not interested in this one. It's always going to be 0 because the right-hand side is 0. So this one here is the smallest positive ratio. So it means that the 3 is my pivot element. And it's important to mark that on, just circle it or just show it on your table clearly. Okay, so I'm just going to add another table underneath. And then we can do our first iteration. Okay, so to continue, we want to make the pivot element, that needs to be a 1, and then every other element in that column has to be a 0. So to start with, it's always easiest to start with the pivot row. So we'd want to divide this whole row by 3. So I'll put the row operation here. So it's row 2 divided by 3. So that S2 is going to turn into a Y. So this time we're increasing it in the Y direction. We know that nothing else is going to change. So if it helps you line up your columns, which it does me, I quite like to just fill in all of the others so that I've kind of got them in the right kind of place in the table. So that divided by 3 is 1/3. That divided by 3 is 1. That divided by 3 is easier to leave fractions if you can. 1 divided by 3 is 1/3. 0 divided by 3 is 0. 5 divided by 3 is 5/3. Great. Okay. So that's our pivot row done. The next, I'm going to do the top one next. So I'd want to make this into 0 using multiples of this. So I'd want to do this, take away 4 lots of this. So it'll be row 1, take away 4 lots of row 2. Okay. So 3, take away 4 lots of 1/3 is 5/3. There's a high chance I might get something wrong here. 4, take away, hang on. Yeah, no, that was right. I think I might have said it wrong, but I did it right. 4, take away 4 lots of 1 is 0, so that's the whole aim of this. 5, take away 4 lots of 10/3 minus 25/3. That take away 4 lots of that is 1. That take away 4 lots of that minus 4/3. That take away 4 lots of that is 0. And that take away 4 lots of that . 10/3. Okay. The next row, so this is the third row in it. To do minus 2, I want to add 2 lots of 1. So it's row 3, add 2 lots of row 2. So that, add that. That, add. So that, add 2 lots of that is 0. That, add 2 lots of that. 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 Okay. And then the bottom row, it would be, so minus 5 plus 5 lots of that. So row 4 plus 5 lots of row 2. So that plus 5 lots of that. That plus 5 lots of that. That plus 5 lots of that. 44/3 plus 5 lots of that. That plus 5 lots of that. That plus 5 lots of that. That plus 5 lots of that. Okay. It was this row that was always tricky. This column that was always tricky. Okay, so there's our second iteration. Now we've still got negatives in our objective row, so we need to carry on because we've got that one there. Okay, so I'm just going to draw out the next. Well, actually, I don't need to just yet. Let's figure out what our pivot element is. So this is going to be our pivot column because it's the one with the most negative value in the objective row. And then we need to work out our ratios. So you can pause it and you can do that. So it's the number in the right hand side or the value column divided by the number in the pivot column. So 10/3 divided by 5/3. So pause it there. See if you get the same numbers as me. So when you unpause it, my answers will be there. And see if you've identified the correct pivot element. So it's the smallest positive ratio that tells us which one we want to use. Okay, so the next iteration, I worked out that they were my ratios. The smallest positive was 2. So that 5/3 there is my pivot element. So again, that's the aim, is to make that equal to 1 and these 3 equal to 0. So S1 becomes an X. So we go across to our pivot element and that's what it becomes. So that becomes an X, that stays as a Y, that stays as an S3, and that stays as P. So in order to make that 1, I would need to divide this row by 5/3. So row 1 divided by 5/3. So that one divided by 5/3 is 1. That one is 0. That one is -5. That one is 3/5. That one is -4/5. 0. And 2. Okay. Now the next one, I want to make that into a 0 by adding or subtracting multiples of this. So I'm going to need to do row 2 take away 1/3 of row 1. So row 2 take away 1/3 of row 1. So that take away 1/3 of that is 0. That take away 1/3 of that is 1. That take away 1/3 of that is, that take away 1/3 of that is 5. That take away 1/3 of that is -1/5. That take away 1/3 of that, 3/5. That take away 1/3 of that is 0. That take away 1/3 of that, 1. Okay. Row 3. So to make that into a 0, using multiples of this, I would want to do row 3 take away 5/3 of row 1. So that take away 5/3 of that, 0. That take away 5/3 of that, 0. That take away 5/3 of that, 15. That take away 5/3 of that. 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 Okay. And then the last